is Colin Murphy. I'm a senior product marketing manager at Microsoft. I'm joined today by Elaine, a senior program manager in Azure SQL Database. Welcome.
Thank you very much for having me.
And today Elaine's going to cover the deployment options that you get with Azure SQL Database. So all those flexible deployment options. Sometimes it can be a bit confusing what to pick when. So Elaine's going to just walk us through some of those deployment options we have available.
Absolutely. So in Azure SQL Database, we have sort of two major deployment options, which is the vCore based model and the DTU based model. And we'll kind of walk through what those different options look like and what's available and sort of how people should think about using these different options. So if you look, we've got a logical server that's already been created here. So the logical server is really the connection endpoint that customers use to get into their database. And this one already has 4 hyperscale databases attached to it. So we just very simply going to create a new database. We'll give it a name. And then you can either choose what the source for that database is. So you can either start with a blank database, as most people would, or you could load up a sample backup for the database, or you could actually do a full backup from one of your existing servers, right? So you can make an identical copy of an existing database that you've got. But for this one, we'll just stick with blank. You would choose the server that it's attached to. In this case, it's a pre-existing server. And then here's the first sort of important option is around elastic pools, right? So you can choose to have this as an elastic pool or to not have an elastic pool. And really what that is a single database is exactly as it sounds. It is a deployment option that is scoped to the database level. So all of your access into that database is restricted to sort of functionality that lives at the database level. So you don't necessarily have access to things like SQL agent and some of the things like that. But that's really where manage instance sits. And we'll be focusing on SQL database for this specific section. So with elastic pools, you can sort of contain multiple individual databases inside a resource container, and that resource container will then govern how much resources the individual databases inside get at any given time. So it allows you to dynamically, or it allows the databases to sort of scale up and scale down within the bounds of that container as workloads require them to.
So an elastic pools option is really for like multi-tenant apps would be a good example. Like SaaS applications would be a good example for using elastic pools as your deployment option.
Yeah, exactly, right. So I mean, if you wanted to run some type of application that, as you said, was multi-tenanted, elastic pool will kind of protect the individual databases from sort of the noisy neighbor syndrome, where they can sort of scale as workload demands, but also not to the degree that one database will kind of influence all the others. But the pool as a whole has a set number of resources that you allocate. But if we then dive a bit deeper and we come look at the individual deployment options that exist within Azure SQL Database, the very first sort of options that you get here are what we refer to as the DTU model. So that's the database throughput units, which is essentially a blended model of CPU, memory, and storage all in one. And this model was really designed, and it was the first one that we had, but it was designed in such a way that the choice of where you land should become easier and you shouldn't have to worry about those dynamics. So these databases have sort of 4 options at the moment. So basic being the really basic ones where you start off with 5 DTUs, and then premium, which can scale up all the way to 4,000 DTUs, right? And the number of cores allocated and the memory allocated are sort of a function of the tier that you land up on. So if we, yes.
So on those tiers you mentioned, so these are tiers within a choice of a database. So can you, if you selected the tier, can you go back or can you go up? Is there any flexibility there once you've deployed?
Yeah, so absolutely. So we allow the existing databases to change tiers. There's one exception to that at the moment, which is Hyperscale, and we'll sort of cover that one individually. But if you were deployed to sort of a standard database today, moving up to the vCore model, which is the other major model, is fairly simple. It's just you could do it through the portal or through PowerShell or CLIs or any of the sort of Azure options that are available to you. So here you can see under standard, we can very simply slide it. We can say, well, we want 3,000 DTUs and how much storage comes with that option that we have. Under premium, you can go all the way to 4,000 DTUs, but I guess the biggest difference between standard deployments and premium deployments is really around the storage, where premium deployments, as well as business critical, which we'll look at next, is all based on locally attached SSDs. So in the physical compute node, there's SSDs that are locally directly attached to the server, whereas standard uses remote premium standard storage, right? So there's a difference in performance characteristics there. So standard is sort of the basic where a lot of people would land up with their workloads. Premium is really for those sort of high IO intensive workloads that some customers demand. One of the additional benefits of landing up in the premium tier is that we allow you to have read scale out replicas, which means you can use one of the high availability replicas to direct your readable workloads to. So you get the ability to not only sort of scale up, but scale out a workload for a read perspective. And then, of course, zone redundancy just ensures that within a single region, a database cannot go down due to failure in a single data center, right? So we would sort of have multiple copies of that data center, but they would physically live in different data centers in a single region, right? And then there's Premium RS. We're not going to spend a lot of time on this because Premium RS, from our perspective, is actually being deprecated in favor of the Hyperscale tier at the moment. Then it sort of brings us on to the next sort of major choice that you have, which is around the vCore model, and this is the newest one. And the vCore model is really about giving customers flexibility in a way that they can make decisions the same way they used to on-prem. So when you buy SQL Server on-prem and you sort of spec out a server, you choose the number of cores you want, the amount of memory you want, and the type of storage you want. And general purpose, the vCore model is really based on that same principle where you buy cores and the memory associated with those cores in this model. And that applies to both general purpose, hyperscale, and business critical. Now, interestingly enough, under the general purpose tier, you actually have more options open to you now. As the vCore model is sort of the newer version of the model, you'll see a lot of our newer deployments will land up in the vCore model. So you have the first choice you get is around your compute tier, where you have provision compute as well as the sort of newly announced serverless. And really the difference there is provision compute is you choose a number of cores, and the number of cores that you allocate will always be available for your workload to run. Whereas with serverless, you still choose a maximum and a minimum number of cores, and your workload can scale up in those sort of bounds that you allocate. But it's really designed for customers with these sort of unpredictable type of workloads where, 1 minute they could require a lot of compute power versus, then for the next 6 hours, there's nothing going on in the database. And serverless will bill down to the second. So essentially we do per second billing, and we will then sort of recover resources from the server when you're not using it. And then after a certain length of time of not using that server, we'll actually pause the whole server. So it's all about sort of cost savings within the serverless tier. But under the provisioned choice, and we'll kind of see this with hyperscale and business critical as well, you then have two sort of choices around the generation of hardware you run. And that's really just sort of an artifact of how the Azure data centers work, in that there's, we're always refreshing our hardware, trying to keep it up to date. So we do have sort of hardware that sort of comes in that's slightly newer and has different characteristics than some of the older things. And there's a lot of things that go into that, like the speed of the CPUs and all of that. But really the major choice that you've got to make here is around the type of cores that you require when it comes to Gen 4 and Gen 5.
Wow, there's a lot of choices here, a lot of choices. So on the serverless, it's really for like those unpredictable workloads. is why you'd really pick that one. And then the provisioned one is if I've got like a workload that's I pretty much know, it's mission critical. It's always going to be at this, this threshold. I would pick this one because I want that mission critical workload to always run.
Yeah, that's exactly it, right? So with provisioned, you would always have the resources you require available. Gotcha. With serverless, because we recover resources, there's sort of this process whereby the server has to kind of come back up as you scale with your workload, right?
Okay. And is there like a time period for when that ramps back up? So I'm just thinking like types of applications, ones that are not so time sensitive, ones which can take a little bit of time spinning up.
Yeah, so I mean the ramp up is fairly fast in terms of increasing your compute. It's actually, in fact, it's very fast. The one thing that could take a bit of time is sort of around if the whole server was paused, there is some type of period that you have to wait before the server actually sort of will be available to accept queries to process. But really the sort of point in time scale up and scale operations, those are completely seamless and they happen fairly quickly, right? Like you wouldn't really notice the difference between sort of running it and then it's scaling up while it was running. Mm-hmm. The one thing that you've always just got to keep in mind with those type of operations is that like as the server sort of gives back resources into the pool, you sort of lose your buffer cache that sits in memory because memory is tightly coupled to CPU, which means there is kind of the notion of sort of having a cold start. Right, gotcha. Like as you ramp up, but generally speaking, it's not majorly significant to most workloads that we see.
Mm-hmm. And then on serverless, you mentioned you mentioned you can set a max, min max for the compute you need in that serverless. And then obviously, I'm saying if you hit that max, what happens when you hit that max?
So when you hit that max, it's really just a case of like you've utilized all the resources that are available to you in that time, and although your query won't fail or you won't have any type of failures, you will just sort of be restricted to the amount of data you can process given the amount of
so you'd set alerts maybe so you can go and increase it, but you'd see maybe a slight slow down in some performance.
Absolutely right, and I think that's it's a good question in that's why the minimum cause also exists, right? So to avoid the sort of the overhead of the whole server pausing, if you have this notion of having a min cause, unless you satisfy the time criteria to pause the whole server, you'll always have some resources available to you. So your startup time is never from zero. It's always from at least the min value that you've allocated. So then if we kind of look through, as we said, there's these two types of hardware that exist. We've here got the tick button for the Azure Hybrid Use Benefits, which is really just a program that exists to sort of benefit customers that have already invested in SQL Server. So if you own SQL Server licenses today, you can bring those licenses along with you into Azure and you'll sort of see a proportionate discount being applied to the price of the instances that you create.
That's great.
If we then sort of just skip over to business critical, again, it's exactly the same principle as what we saw in premium, where you have the two hardware generations, but you also have this option to enable read scale out replicas to offload that workload. And that's really a benefit of landing up in business critical. So if your workload is designed in such a way that you need high IO throughput, but also you might have large read workloads like report generation or cube generation. Those can all be offloaded onto the secondary without impacting your sort of primary OLTP workload.
Okay, so business critical for just higher read writes, OLTP workloads, transactional workloads, and the read scale out as well.
Yeah,
those are the two primary capabilities you're going to get with business critical. Anything else you get with business critical? I'm assuming you're paying a slight premium there for that.
Yeah, so I mean, within business critical, there are sort of from a functionality perspective, all of our deployment options are the same. The one that kind of stands out under functionality is any of the in-memory objects that exist. So in SQL today, you can have hackathons, so you can have like in-memory optimized file groups, or you can have in-memory tables that exist. Purely as an artifact of the underlying infrastructure that we run on top of, business critical is the only tier that supports in-memory objects today.
Okay.
Right. So apart from that one sort of feature, everything else is supported across the platforms, and really what you're purchasing here is a performance tier.
Gotcha.
And then the last one that we'll look at here is just Hyperscale. So Hyperscale is interesting in that it's our sort of it's one of our newest deployment options, and it's really designed for customers that have very large databases, but also more than that. What we did with Hyperscale was we redesigned the entire storage engine for SQL. So things that used to create major bottlenecks in SQL servers around storage and how sort of logs work and log applies work, a lot of those things we've tried to tackle with Hyperscale. And it has sort of opened a huge new set of opportunities that customers can take advantage of. So with Business Critical today, the largest database you can have is 4 terabytes. With general purpose, it's 8 terabytes. With Hyperscale, we can go all the way to 100 terabytes. And there's no relationship between how much storage you have and the number of cores that sit in the service. So you could have 100 terabytes running against 2 cores. Your queries might not perform great, but I mean, you could have that, right? Like if you were using this to store data.
So we separated the compute and storage completely.
Completely, yes.
Okay.
So here on this specific Hyperscale one, we can choose the number of cores. If we go to Gen 5, you can go all the way to 80 cores. The other one that's very interesting with Hyperscale is similar to what Business Critical has, all of those readable secondaries. Because of the way we've structured the storage layer in Hyperscale, we actually allow you to have up to 4 readable replicas now. So you could have, your single primary workload, and then instead of scaling your workload up, you could scale your workload out by adding these readable secondaries and sort of offloading that workload into those readable secondaries.
So how long does it take if I wanted to? So let's just say I've got a 100 terabyte database, and I now have a mission to go have massive amounts of reads on this database for reporting purposes. I've got thousands of people wanting to connect. How long does that take to scale that out?
Yeah, so that's a good question, right? So in Hyperscale, we sort of introduced the concept of having these constant time operations, and what that really means is your storage is kind of the central pinning pillar for your database, but it does give us the ability to now attach multiple compute nodes to a single set of storage. So normally what takes a lot of time when it comes to scaling up and scaling out operations is duplicating your data, right? So you need these multiple nodes that all contain the same set of data, and then keeping all the data up to date all the time, right? That's how a traditional sort of high available SQL deployment works. With Hyperscale, we've kind of turned that on its head, and we've said, okay, well, instead of that notion, you now have your storage as the central pinning piece, and you can attach multiple computes to the same set of storage. So your ability to scale up and scale out is a fixed point in time, because we're not having to copy the data, right? So generally speaking, for like the 95th percentile, most people can scale up and scale out in under 10 minutes.
Wow.
And that's anything from 2 cores to 80
so
cores.
These would be operations like they're scaling up would normally take like, some people would say a DBA would take like a weekend or, 3-4 days to.
Yeah, absolutely, right. And I mean, even within our other tiers, if you think about general purpose and business critical, I mean, all of those operations at some point become size of data, right? So even in business critical, if you do a sufficiently large enough scale operation, there will have to be this function where we move your data out of the existing system into the new one. And that movement of data is really what's taking all the time. Whereas in Hyperscale, we can guarantee that never happens, right? So the only thing that's really taking time here is the creation of the new nodes and attaching them onto the data. So for this demo, I'm just going to choose a 2-core. I'm going to select 0 replicas, purely for the purpose of this demo. The one thing that I do want to call out with Hyperscale is it is a fairly new sort of service tier that we offer within Azure SQL Database. So today, there is no way for you to migrate away from Hyperscale. So earlier we said that yes, it's easy to migrate between the tiers, with Hyperscale being the single exception to that it's easy for you to get to Hyperscale. It's currently not easy for you to sort of get out of Hyperscale, but that's absolutely something.
So you can migrate to it, but once you're there, that's it.
Yes.
But obviously the reason why you're there is probably because, you've got a very large database and you're growing and the other ones wouldn't support it anyway.
Absolutely. But again, just to be super clear, that is definitely something we are addressing, right? It is something that we will in the future enable customers to freely move between these tiers as their workloads require. So, I mean, this is it's not a permanent thing. It's just customers need to understand that today that limitation for Hyperscale does exist.
Okay, so let me just read up. So we've got these deployment options of elastic pool, single, managed instance, and then we've got these service tiers underneath, which is Hyperscale, your business critical, and your premium.
General purpose
general purpose and your premium.
Yeah,
gotcha.
Exactly that. So it's two different axes, right?
Two different axes, yeah.
So it might sound complex, but it's not that complex when you look at it sort of top down. There's three deployment options, and then there's three service tiers for them. And the service tiers are really about performance and requirements, whereas the deployment options are really about functionality and surface area exposure that you're interested in.
Yeah, and like you said, we give customers the flexibility to move around between this. So, they got that choice and flexibility to move around.
Yeah,
from the Hyperscale.
Absolutely, right? And that's super important, right? So being able to move sort of in and out of the different sort of service tiers and deployment options is very important. And it's something that we will sort of continue to address, especially with Hyperscale now, because we don't like the notion that it's sort of a finality. So we'll definitely be dealing with that in the near future. So if I just apply there, I've selected a 2-core Gen 5 Hyperscale. I can then select the correlation on my database. I can specify a custom correlation if I want. And then it's really just a case of hitting the OK button and off you go, right? And now in the back end, what it's going to go do, it's going to go create an entire new database. It's going to attach it to the logical server, and that database will then become available for me to use within a couple of minutes. So if we just refresh this page, we might be able to see that it's already coming up over here while it's still creating. So wait for my browser to refresh. There we go.
Wow, that's really cool. I didn't realize we have a lot of options for customers to pick the different tiers and deployment options.
Yeah, and it's all around flexibility for customers. My browser's not. There we go. It's back up. Let's have a look now. All right, so it's not showing yet, but it will show up within. It usually takes about 2 to 3 minutes, and then that new database will be available for you, and you can connect to it and sort of get started straight away.
Oh, perfect. So this is obviously it's all on obviously it's Azure Cloud, so it comes with all the SLAs, the 4 nines, all of these deployment options and tiers do. So this is great. Wow, thank you, Elaine. Thank you for explaining this to us. So everyone, hope you got an understanding of our deployment options and deployment tiers for Azure SQL Database. Give us a like or subscribe to this channel for the future shows, and we'll share a URL where you can get more information on these deployment options. So thank you very much.